Hello, friends. Welcome to Coding Garden with CJ. Welcome to Katas, Code Katas number, wait, what is it, 14? Yes, number 14. Wow, we've done so many of these. It's going to be a fun time. If you check the chat, I linked to all of the katas that I will be solving tonight, but let's talk about it here. So if you're new to the show, if you go to github.com/codinggarden/code-katas, you can see all of the katas I've solved on past episodes. And if you click on today's date, here are the links to the ones I'm going to try to solve today. I say try. I usually get it. I don't know. But lots of people in the chat. Let's say hello. Jimmy, welcome to the stream. And Ran, welcome. 3K, congrats. Yeah, I'm at 3,000 subscribers. It's pretty awesome. Hello, Ed, who's in Chile. And Alicia. So Alicia made a rhyme. Yay for the 3K. Hey, CJ. hey, Alicia, welcome to the stream. And Oliver, welcome. And Daniel Davis, tuning in right from the beginning. It's going to be fun. So we have four katas picked out for tonight. The first one is a 7Q called 2-to-1. We then have a 6Q called duplicate encoder. We then have Memoized Fibonacci, which is a 5Q. And then lastly, we have a 4Q, which is Snail. It's going to be fun. Hello, Andreas. Welcome to the stream. Yeah, and Ran is saying the 4Q scares me. It kind of scares me too, but if you tuned into the Noob Quest stream on Saturday, actually, I'll show the game that we made. We made front-end opoly. So you can choose your pawn. Let's say we do Vue versus React. And then you get a game board where you can roll the die, it moves your pawn, and you get points for landing on your own square, whatever. But this was a challenge because this was a grid, and we had to place the squares exactly along the outside edge of the grid. And so it was a similar algorithm that we're going to have to do here for Snail. I don't know. But let's get started. So the first one is called 2-to-1. Excuse me. Take two strings, S1 and S2, including only letters from A to Z. Return a new sorted string, the longest possible, containing distinct letters, each taken only once. So for example, if A is a string with all of these letters, and B is a string with all of these letters, you need to create a new string with all of the unique letters from both in sorted order. Or for example, if you pass in two strings that are exactly the same and already sorted, you should return that same string sorted. So basically, you have two sets of strings, you have to mash them together, only get the unique ones, and sort them. So let's get started. Oh, and Tony's in the chat. Look at those pawns. Oh, actually, shout out to, let me pull up his name. So the front-end opoly game is on GitHub. You can make pull requests and add new features or fix things if you'd like. But Thomas Andrew McLean actually added a few features, which I merged in. So you'll notice whenever you select a pawn, you get that nice poof. He added that. He fixed some styling with the logos too. I think he fixed something else too. But shout out to him for making that contribution. Okay, let's do this. I'm going to bring this code down locally so I can use Quokka. So let's create a new file. Let's call it 221.js. That's our function. We can grab our tests here. And let's just turn these into console logs. Okay. Let's start up Quokka. Quokka start on current file. Cool. So right now our function is returning undefined because we haven't written anything yet, but these are our expected outputs. Hey Amy, welcome to the stream. But okay, so what do we got to do? So S1 is going to be this, S2 is going to be this. Really, we need to get all of the unique letters from both and then sort them. So like at a high level, get all unique letters from both S1 and S2, sort the unique letters, return the unique letters sorted. Okay, so we've broken it down into like two steps, but now how can we get all of the unique letters from both S1 and S2? This is something we do on almost every stream, but basically we could build up an object where we keep track of the letters that we've seen before, and that way we won't have any duplicates. So here's what I'm thinking. So to get all the unique letters, we have a place to store unique letters. This will be like an object. And then we'll iterate over S1. And if we have not seen, so iterate over S1, and basically for each letter in it, if we have not seen this letter, add it to the unique letters. Okay. And then we do the exact same thing for S2. And then at this point, we have all of the unique letters. Okay, then we need to sort them. I think initially I'll just use like built-in sort from JavaScript. So really we'll need to get all of the keys from the unique letters, because we're going to have an object where all of the keys are letters and the value will just be like true because we've seen it before. So we'll get all of the keys and then use built-in sort to sort the keys. Okay. Ooh, AJ has some good suggestions. So I'm going to go with this solution first. But AJ mentions we could use a set. So a set is a really easy way to only grab unique things because a set doesn't allow duplicates. But let's solve it this way, and then we'll try it some other ways. Okay, so to get all the unique letters from both S1 and S2, first we need a place to store them. So let's say unique letters is an object. And basically what we're going to do is as we iterate over them, we'll say like A, true, B, true. And this means that we've seen those letters before. So if we haven't seen them, we'll add them. And if we have seen them, they'll already be in there. So that's what we'll end up with. But we first start with an object. And now let's iterate over S1. So let's just do a simple for loop. Again, we'll refactor this. We'll use like a reduce. It'll be great. But let's say we have a for loop. Started off at 0. It goes less than S1.length. S1 increments. So we're iterating over each letter in S1. And if we have not seen this letter, add it to the unique letters. Technically, really all we have to do is say, well, let's create a variable for the current letter. So current letter is going to be S1 at I. So that's going to grab that specific letter inside of the string. And then we can say unique letters bracket current letter equals true. That's pretty much all we have to do, because in JavaScript, bracket notation allows us to create a property on an object, and current letter will be each individual letter. And so technically, we don't even have to see if we've seen it before, because we can just, we'll be overriding the same value with true. So let's just log out unique letters here. Unique letters. Wait, did I spell that right? Unique letters. And for now, let's only do this one. So, wait. Oh, sorry. I incremented S1. Silly me. I need to increment I. Okay, there we go. So after iterating over S1 in the first example of are they here, we end up with an object with all of the letters, and each one is true, but we don't see the letter more than once, so that's a good sign. And basically, we need to do this exact same thing with S2. So right now, I'm going to copy and paste it. We could write a nice little function that like does this with like you pass in a string and adds it to an object. So we can do the same thing with S2. And then now after both of those loops run, we can look at unique letters. And we should see all of the unique letters from both S1 and S2. And in this case, like S was the only new letter in this other one. So cool. And hello, Rodrigo. Welcome to the stream. This is my break timer. It's my longer break timer. I'm not going to take a 5-minute break. I did take a break before we got started. But okay, so we're doing good. We have all of the letters the unique letters from both S1 and S2. Wonderful. So now we need to get all of the keys. So that object had all the unique letters. We need to just grab those things off. Built into JavaScript is object.keys. And this will give you all of the keys of an object. So I want all of the keys of unique letters. Whoa. Unique letters. Cool. And then we want to sort it. Let's look up JavaScript sort. I think JavaScript sort I think it does it in place. So we might need to sort it, then return it. Let's look up array sort. Yes, the method sorts the elements of an array in place and returns the array. So we should be able to simply do this. Say return letters.sort. Well, we're going to have to turn it back into a string. That is sorting them. Great. And then we want to take that array and make it back into a string. So join it. We've done it. So let's try it with all of these. And we get the expected output. So that's great. We have a pretty verbose solution, but there are some more things we can do with it. We have some good suggestions in the chat for like using a set. Let's do this first. So let's kind of like refactor this to, so when you're thinking about refactoring, you typically see like duplicate code, right? Like the only difference between these two for loops is the fact that we're iterating over a different string. So let's turn that into a function. So here's what I'm gonna do. I'm just gonna copy and paste it and we'll rewrite it here. Cool. Okay, but this is a function. So we need a function. Actually, let's just define it inside of the function here because that way it'll be easy to submit if we want to submit this one to Code Wars. But let's just create like an inline arrow function. Let's say add unique letters. And this is a function that takes in some string. And then it needs to do this right here. But instead of S1, it'll be str. Actually, and sorry, we do need to iterate over it. So we need the whole for loop. So this whole for loop goes into this function. Now instead of S1, we do str. And now that we have this function, we can just call it twice. So we'll say add unique letters with S1, and then add unique letters with S2, and I should do it. Cool. Cool. And hello, Andre. Welcome to the stream. So that's a nice refactor. We could technically turn this into a reduce of sorts. I say of sorts because technically we're reducing down to that object, but we're doing it twice. So you know what? Here's what I'm gonna do. So let's leave that. So that was fun because we created a function. Now, instead of creating a function, what if we just did this? So we have one for loop. We create a new variable. It's like all letters. That's S1 plus S2. And then now we just iterate over all letters. And then we don't need to call the function. And that works in the same way. So that's fun. But now that I have a single loop here, I could turn this into a reduce to unique letters. So I want to reduce all letters. So first we have to turn it into an array before we can reduce it. So let's say like all letters dot split turns it into an array. Then we can reduce it. We're going to be reducing down to unique letters. And we're going to get access to each current letter. In your reduce, always remember to return your accumulator. And our accumulator starts off as this value here. So the second parameter to reduce is that. And then what goes in the reduce is what's inside the for loop. And then we can get rid of all of this code right here. Okay, that works in the same way. So now we've taken all the letters, we've reduced them to this object, and then we're grabbing the keys and sorting and joining them. And just for fun, let's try to get this like all on one line of code. So we could say, let's do this. So all letters could just be that. And then technically we want the keys of this whole thing. So let's do this. Let's return object.keys of this whole thing. Okay. And then we need to sort and join that whole thing. Okay. So now we're doing it all almost on one line. If we made our variable shorter, we could do it on one line. Let's just do that. One last thing, and then we'll try out the sort. Oh, good call. So Oliver is mentioning, so like if we, for the for loops up here, if we use a for of, that will actually give us each letter in it, and we wouldn't have to index into it. I think I'll show that after this. Okay, so we've got this. Now let's, instead of saying unique letters, just call it all. And let's call current letter L. Cool. I guess technically it'd be, we can't exactly put this on one line because the this does need a return. I mean, we could do this. pretty sure we could do this, and it still works. But that's ugly. Okay, but that was fun. Let's try out a set, as AJ mentioned, and then Oliver mentioned you can actually just pass the string into a set and get all of the unique things. So let's try that. So we have a function called longest. It takes in S1 and S2. Sorry, yeah, S1, S2. And basically, here, so that, like these unique letters that we're building up are actually, we could use a set. Let's look at a set on MDN. Set. Capital set. There we go. The set object lets you store unique values of any type, whether primitive or object references. Interesting. So you can create a set by passing in an array, but apparently you can also pass in I'm looking at the chat, but I'll come back to it. But apparently, Oliver mentioned you can just pass in a string and get a set out of a string. And then with a set, even if there were duplicates in the thing that you passed into it, it automatically pulls those out. And there's the ability to grab the entries. So set.entries, it actually gives us an iterator. Can we do .values? It does give us an iterator. I'm just saying it gives us an iterator because we actually need it to be an array, but I believe we could spread it to turn it into an array, so that way we could sort it. Regardless, let's try it. So we need a set. Let's call this unique letters. And this is going to be a new set. And what I see is we can actually just pass in S1 plus S2. And let's see what we get with that. Will it log out? Let's only run this first one. Very cool. So look at that. Very minimal amount of code required. We can create a set with the two strings, and it gives us all of the unique values. Awesome. Then we need to sort them. So there's probably not a way to sort a set, but what I was mentioning is like we could do entries, but it gives us an iterator. Let's just see, no, because I don't think an iterator has sort on it, but this is what I'm thinking. Can you do like unique letters dot entries dot sort? Probably not. Sort is not a function. Yeah, you can't do that. But what we could do is, I think, can we spread the set or spread the entries? Let's do this. So create an array and spread, I guess not. Entries aren't what we want. Is it values? We may actually want values. Values. Yes. So create the set, turn that set into an array by grabbing its values, and then we sort it, and then we join it. Cool. That's a nice, clean solution. Very cool. And it should work with all of these. It does. There was a suggestion for, oh yeah, so the reduce, I'm seeing I can turn that into a one-liner. That's super interesting. Because, well, I think you have a missing, your parenthesis is off in one place, but when you add to an object, does it actually return the object itself? Because if that's the case, you can make it a one-liner. So like, we have our object equals that, object equals that. And if I say object at hello equals world, does it give me back the object? No, it just gives me back world. So that's why I think that may not work, Oliver, but let me try. Hello, JP. Welcome to the stream. And Zika has a question in the chat. What plugin do you use to display the console log in the editor? So this is a plugin called Katas.js. It's really great. I first found out about it by watching Fun Function, which is an awesome YouTube channel I used to check out. Fun Function. He has some videos on setting up Quokka, but it's super cool. It's supported in VS Code, in WebStorm, in Atom. But yeah, it runs the code inline. There's some limitations with the free version, but you can get a license for the pro version, which has a lot more stuff built in. Oh, okay. I'm going to try what Oliver is suggesting because that's super interesting. Okay, and this was specifically for the reduce, attempting to put it all on one line, but without the return. So what I'm seeing is reduce, unique letters, and current letter, and then we're using the comma operator. Let's see. Oh, weird things are happening. Here. Okay, so we'll say all at L equals true. And I pass in all, and this is in parentheses. Oh, sorry, not all. This is like that. Because the comma operator counts as one line. Let me see if I'm doing this right. Okay, so we have our reduce that takes in, there's the beginning of the function, fat arrow, parentheses, set the value, return the value, but for whatever reason it's telling me all is undefined. Where is all undefined? Here? What if I mean, right now, what if I just did, just for clarity's sake? Why is all not defined? Am I doing this wrong? It's a value there. This is the function. What? What do you mean? All is not defined. What am I doing wrong? Oh! I was missing a parenthesis. Okay. Which means I should be able to do that, comma all, put this, yeah, and that works. Good call, Oliver. That's super tricky. So basically we can do a one-line function like this. So you do the assignment, but then the comma operator basically says, this is another thing, and with an arrow function, the last thing in the statement is what gets returned, so that works too. Super cool. Okay. I'll put this one up here. Yes, here. Because I really like this set one. That was a good call from AJ that recommended using the set. Okay, let's try it out on Code Wars. We'll submit it, see what happens. Sample tests. Seems to work. We'll do an attempt. It worked. Awesome. Great work, everyone. What's happening? I can't see the button. There it is. And Google, Oliver mentions in the chat, comma operator is the worst thing for readability and should never be used. I totally agree. Like, I would never, if this was like a production code base, write this on one line of code. I do like this. So this is 2 lines of code, but it's as long as you know what set is and you know what the spread operator are, it's very concise and describes what we want to do in as little as possible versus having like all of this stuff happening like on one line. Cool, that was fun. Let's look at some of the previous solutions. This is basically what we did. Create a set, sort it, join it. Array.from set. So you can use array.from instead of using the spread operator. At the end of the day, it does the same thing. And actually, I guess I didn't have to do dot entries. You can actually just spread the set. So what I did, dot values. So it should actually work just spreading the set itself. I didn't know that was a thing. Okay, cool. And I'm guessing that works because set itself is an iterator, so the spread operator works on anything that you can iterate over. Cool. Split it, sort it, filter it. Wait. So they filter it, but like they're looking at the value inside of the array like before it. Okay. I like this. So it's like, because it's already sorted, the first time you see something, it'll return true for the filter, but the second time you see it, which would be immediately after it, you return false, meaning the duplicates don't show up. That's an interesting solution. Yes, and Rodrigo mentioned lesson of the day, one-liners are not always the best option. Mainly because I got tripped up on a missing parenthesis. I don't know. It's fun to do, though. All right, let's go on to the next one. Duplicate encoder. The goal of this exercise is to convert a string to a new string where each character in the new string is parenthesis. If that character appears only once in the original string, or closing parenthesis, if that character appears more than once in the original string. Ignore capitalization when determining if a character is duplicate. So I think, again, we can create a, let's start off with set. So now we know what set is, we can use it. We could create a set of all the letters and then iterate over the letters, but probably map over them. Returning either opening or closing if the thing is in the set. Wait, no, not the set. No, we need to know whether or not there's duplicates. So I don't know if we probably can't use a set because we lose that information. Regardless, let's try it. So I'm going to bring this down locally. New file, duplicate encode.js. And let's bring down our samples. Okay. Hey, Tiger, welcome to the stream. Yeah, and so Oliver is mentioning, so if I did use a set, I would lose the information that there are duplicates. So I think technically we want to do a similar thing that we did before we used a set last time, where basically we kept track of things, but now instead of just storing the unique values, we need to store like whether or not it is duplicate. So, okay, so let's iterate over the word, and we need a place to store whether or not a letter is a duplicate. Okay, iterate over the word. If we have seen this letter before, set to true in this place where we're storing things. Else set to false. So if we haven't seen it before, we're going to put it in that object as false. And the moment we see it again, we'll swap it to true. So now we have an object with all of the letters and then true or false as to whether or not they're duplicates. Great. Now we'll iterate over the word again. And now we need a place to store the parenthesis. And we'll iterate over the word. If we have seen this letter, well, not if we have seen it. If this letter is a duplicate, append a, what was it, closing or opening? Closing. Append a closing parenthesis. Else, append a opening parenthesis. And then return the parentheses. Cool. Yeah, and before I even get into coding this, JP is asking, what exactly is the benefit of using set? The main idea is if you want only the unique things. So for our specific case, we're given two strings. You think of, I mean, really you could just think of it, okay, in this one big string, what are all of the unique values? And in this specific case, a set allowed us to pass that in, and a set only holds on to unique things. So specifically, if we look at set, please, set. The set object lets you store unique values of any type. So, and it has a few methods on it. You could say has. So basically, you could put things in a set, and if you want to know whether or not you've seen that before, you can say set.has something, and it'll tell you whether or not you've seen it before. This is much more performant than like searching an array to see if you've seen it before. Probably about the same performance as if you were to just look into an object and see if there's like a true-false property or something like that. Cool. And a question from Tiger: is there any course coming? I would love to see a course in terms of like a video course that I make. Not exactly. Do you have anything in mind? Like I definitely have talked about it in the past. Lately, I've been pretty busy with work. As you've noticed, I haven't been streaming as regularly as I used to. But eventually, I do want to make some video course content. Yeah. So I created a React tutorial that's building a CRUD client. Would anyone in the chat be interested in seeing that right now? Because at the moment, I only released it to my students and to Patreon and donors. But I could make it available to the world if anybody's interested in that kind of thing. Let me know. Are you interested in a tutorial on building a CRUD client with React? Let me know. Let me know. Okay, so yeah, that's about set. We have our pseudocode. Let's code this thing. So a place to store whether or not a letter is a duplicate. So let's create an object. Is duplicate object. Okay. Now iterate over the word. Let's use a for loop. I is less than word.length. I plus plus. Okay, so if we have seen this letter before, set it to true. So with so this is where it's going to be interesting, because I would be tempted to say like, and first let's create a variable for the letter. Letter is word at I. So I could say if is duplicate at that letter, thinking, okay, if we've seen this before, is duplicate is set to true. But if I haven't seen it before, that's a extra parenthesis, is duplicate is set to false. But think about this, because if I set it to false, this will always be false. So I can't just use bracket notation to see if the property is in there. I need to use something else. I think I could use the in operator. So if I could say, I think I could say if letter in is duplicate. Is that a thing? I think that works. I could also use has own property, but at this point, let's log is duplicate. See what we get. I'll start up Quokka. So let's just try this first one. And for din, we should see din, and all of it should be false. Yes, false, false, false. Because none of those are duplicates. But if we try it with recede, we should see everything false except for e, because e is the only duplicate. So this is one way to check and see if a property is inside of an object. Another way you might see is using has own property. So is duplicate dot has own property letter should do the same thing. Cool. I like the in operator though. It's cool. It's fancy. Okay, so the chat is saying yes, they would be interested. Yeah, and I've read a lot, and some people have talked about Udemy lately where they don't have the best practices. Yeah. And I have thought about, like, I want to pretty much build my own site where I can host the courses, and then just like use Stripe payments or something like that, where you can like just build it myself. Like that way, I don't have to pay percentages to anyone else. Right, and it's all my own stuff. So I'll probably do that eventually. Maybe not anywhere in the near future, but let's say this in celebration of my 3,000 subscribers and all you wonderful people that are watching live right now. I'm going to make this React thing public. I will say I made it in roughly 2 or 3 hours, so there might be some issues. I know. So my students have gone through it; they were okay with it. But I'd say the one thing that I am wary about with this is there's a lot of like ES6, ES7 things that I do that I don't just sit down and explain. I kind of just do them in a rush. So, I mean, if you're interested, check it out. Let me know. But here's what I'll do. Right now, it's a private playlist. I'll make it public to the world. Playlists. Build a CRUD client with React.
Hello, friends.
No. Let's go here. Unlisted. Are you ready? Drum roll. Public. Cool. So in it, I use React Router, and Bootstrap, and build a CRUD client. Check it out. Let me know if you like it. Like I said, I made it in a few hours. There are things that I do that I don't necessarily explain, like I maybe have in my past videos, but check it out. Let me know what you think. Can I just share this link? There you go, friends. Also, don't complain if it's horrible. Well, do complain. Like, leave feedback. Leave me comments. Be like, hey, what are you doing right there? You didn't explain it. I'd be happy to explain it and like maybe update the videos too. Okay. Where were we? Here. Awesome. So we have an object. It tells us whether or not these things are duplicate. That's beautiful. Now, let's keep on going. So now we need a place to store the parentheses. So let's say parenthesis is plural, isn't it? Empty string. We then need to iterate over the word. Well, I is less than word.length. I plus plus. And yeah, here we go. If the letter is a duplicate. So so we need a variable for the letter. If is duplicate at I, append a smiley. So parenthesis plus equal smile. Else, whoa, append a frowny face. Frowny face. And this should be a let because we're reassigning it. And then let's return it. So return parenthesis. What did I do? Did I? Let's see. Weird. Okay, this first one worked beautifully. So if not I. Sorry, this should be letter. That's why. Okay, there we go. So din, all of them are not duplicates. So it's frowny face, frowny face, frowny face. Recede has like not duplicate, duplicate, not duplicate, duplicate. So you end up with these pairs of parentheses. Should ignore case. We have not accounted for that. So success should count as a duplicate, and we're not counting it as a duplicate. So here's what we need to do. Whenever we put the word in, we'll say this to lowercase. And then whenever we'll put the letter in, and then when we pull the letter out, let's also say to lowercase, and that will account for uppercase and lowercase letters. Cool. Yes, Oliver's keeping me honest. Should be case insensitive. And then this one works too. Fun. Okay, let's make it fancy and shorter. So let's get rid of all my comments. Okay. Let's turn this into a reduce because we're reducing the word into an object filled with true and false, right? So word is a string, so we would need to split it and then reduce it. I'm going to do something here that I've done on past streams, but I haven't explained it exactly. So we could do word.split. That turns it into an array. But we could also do array.prototype.split, call it on word, and not split. Rewind. We split it because we want to be able to use reduce, because reduce only exists on arrays, right? So instead of splitting it, we can directly call the reduce function, so array.prototype.reduce, so we call reduce from the array prototype and say, hey, reduce, pretend that word is an array. So you pass it in, and then now you can give it your reducer function. So we'll say like is duplicate, and we'll pass in like letter. And we'll start it off as an object. But basically what this does is instead of having to iterate over to split it and then reduce it, all in one go, it does the reduce just over the string. So that's cool. So let's say this. And then all of our code in here goes inside of the reduce. And we need to update some things like that. And then we need to return is duplicate. Am I doing something wrong? Din is not a function. What? Let me catch up on the chat. Oh yeah. So, and Rodrigo was mentioning like the post that I'd read about a while back. Like somebody were selling their videos privately or like somewhere not Udemy, and then some random person uploaded those videos to Udemy and started charging people for it, and then people actually started buying them. So like this person was making money from courses that they didn't even make themselves, and then the guy tried to get them taken down, and it took forever. But yeah, they have some interesting practices. Oh, good call. Oliver mentions I need to call the function. So array.prototype.reduce.call. And so that will invoke reduce with word as the this of reduce. And so this should work in the same way. And it does. But But now, instead of like splitting it and then calling it, we can just use the reduce function itself. Cool. Similarly, we can, so we're reducing an array to an object here. We can also reduce the array to a string and just return that. So let's do that. Let's return array.prototype.reduce.call on the word. And we're going to get the parenthesis, and the letter. And then we'll do this. Parenthesis starts off as an empty string. And then this code goes into the reduce. Pew, pew, pew. Need to make that. And then always remember to return your accumulator at the end of the reduce. Wonderful. Hello, Sean. Welcome to the stream. Finally catching Katas live. Love the series. Awesome. Glad to hear it. Yeah, so that was fun. I think we can do better though. So basically, let's do this. Actually, I'll rewrite it in a second one. So this was fun. We basically rewrote both of those loops as reduce, and then we're able to get to the answer. But what I'm thinking is we can make that second reduce a little bit smaller by doing like a ternary return. So right here, so basically we want to return, so if the letter is a duplicate, then we need to return parentheses plus smiley. Else, we need to return parentheses plus frowny. And then all of this goes away. We should get the same thing. Cool. Hey, Chris, welcome to the stream. Oliver's asking, but can you get it to one line? I think I can try. I think we can use your fancy parentheses trick. Well, let's also make this one a one-liner because we could do a similar thing. So we could do return. So if letter, this all has to be in parentheses. So if letter in is duplicate, then is letter at that equals true. Else is letter at that equals false. Comma is duplicate, which will return it. And then this all goes away. Yeah? Yeah? It's getting a little bit harder to read. What if we called this dupe? It fits on the screen, but is it as understandable? I don't know. We could go even further and like put this on the same line. I think I'm gonna stop there. Actually, let me change that variable back. I'm gonna stop there. I'm gonna submit this one on Code Wars and see what happens. Sample tests. Okay. Attempt. Okay. We're doing good. We're making good time tonight. We got 2 more to do. Snail is probably gonna take me like 4 hours, but we'll see. Psh. Oliver says, psh. Okay, go. Cool. JP is saying just a few more lines and you could go for a code haiku. How does a code haiku work? I mean, like a haiku is like number of syllables. Is code haiku an actual thing? Haiku? Probably not. Yeah, AJ is mentioning I could do is duplicate letter.to lowercase. The only issue with that is I need to do it in multiple places. So I need to do it. Let's do it on another one. So I need to do it there, and I need to do it there, and I need to do it there. Cool. That's technically a one-liner, so I could even get rid of the curly braces. And that works. And then I could do the same thing here. And this is already a one-liner, so I can just get rid of that. Cool. That's ridiculous. Let's zoom out and see if we can fit it all on the screen. I can't even fit it all on the screen if I zoom out. I could rename the variables. Why are we doing this? Dupe. That's fun, right? Rodrigo is asking, when am I going to do Code Katas and Golang? I thought about it. I think that would have been too ambitious for tonight because I'm a bit out of practice, but in terms of just like solving coding problems in general. But soon, I think I should. I really, it's like just like challenging myself to learn a new language. I'm extremely partial to JavaScript though. Like it's a really good language for building APIs in, just because like JSON is the language of the web, and JavaScript handles JSON really well. And with like all these other languages, you have to create like statically typed versions of the stuff you're using. I don't know, but soon. This is interesting though. So I haven't talked much about performance tonight. But what you see me doing is like 2 iterations, where there might be solutions where you iterate inside of another loop, and technically that can be like a lot more computation, because like the longer the word is here, the more computations you would be doing if you had like a nested loop. I'll check out what Oliver posted, but to mention, so they're using a similar thing here, but instead of creating that object first, they're using index of. And basically, this has to search through the whole array to find the index of it, and then last index of searches in reverse to find the last index of it. And if they equal to each other, then that means we've only seen this thing once. But if they don't equal, that means it's a duplicate and we've seen it twice. However, it has to iterate every single time to like find these indices. But with our solution, by building up that object first, it's instant to know whether or not it's a duplicate instead of having to search the array. So it's a little bit faster. Yeah, the thing is, because JavaScript has this stuff built in, I see people doing it all the time, like especially on Code Wars, like they're doing it here too. And notice, this is a loop, but inside the loop, we're asking for the index of the thing that we're iterating over. So it can definitely get a bit more complex. Nested loop. See, people are crazy about these nested loops, but I don't know, man. I don't know. Okay, let's keep moving. Yeah, and Oliver mentioned in Discord, they posted a one-liner. Let's check it out. Yeah, and AJ is mentioning O of n squared. They just started learning about complexity of an algorithm, because the thing to think about. Okay, this is a simple code kata problem. It's it was a 6Q, so it's not, you're not supposed to be that performant, I guess. But in the real world, like, what if you had a word that's like length 1,000 and you have a loop inside of it? So it's like, it just compounds. The longer the word gets, the longer this thing is going to take. But let's see Oliver's solution. Duplicate encode. Whoa. Courtesy of Oliver. Sorry, me, I am, so me. Whoa. So cased is the letter itself. We are then putting it to lowercase, splitting it on empty string. So you're lowercasing it, turning it into an array, and then mapping over it. And then for a given word, we're reducing that word. So this is giving us that object. But basically, you're computing that object every time. So like on every iteration of the map, you compute the object to then see if it has been there. Is that right? So on every iteration of the map, you create a new object to then map over. Whoa. Why is this in an array, though? Okay. The outer map runs once. Cool. Super interesting. All right. Memoized Fibonacci. Okay. Problem context. This is a 5Q. The Fibonacci sequence is traditionally used to explain tree recursion. So you might have solved this a similar kata before, but it's you can create basically a recursive function. So the Fibonacci sequence is numbers in a sequence. Let's look up the Wikipedia. Fibonacci sequence. Because it's a number sequence where each number is the sum of the two previous numbers. So we have 1, and then 1 plus 1 is 2, and then 2 plus 1 is 3, and then 3 plus 2 is 5, and then 5 plus 3 is 8, and then 8 plus 5 is 13. And the idea with, I guess, summing up Fibonacci numbers is to find a given Fibonacci number, like, so to find the 10th or the 5th number in the sequence, you have to compute all of the numbers before it to actually get there, because you have to add them up to get there. So the idea with this is it's not very performant, because every time you call Fibonacci, it has to calculate all of it again, and then calculate all of it again just to get to that next number. So what we want to do is make it so that if we've already calculated, let's say, the 5th Fibonacci number, when we run this function again, or like recursively, instead of having to calculate all the way down again, we can just keep track of what we've calculated before. Oliver's saying, now this one I should be able to do on one line. Maybe not at first. But yeah, let's read their description. This algorithm serves well its educative purpose, but it's tremendously inefficient. Not only because of recursion, but because we invoke the Fibonacci function twice, and the right branch of the recursion recalculates all the Fibonacci numbers already calculated by the left branch. So when we call Fibonacci n minus 1, it's got to calculate that by summing up everything. When we call Fibonacci of n minus 2, it's got to calculate that. So this algorithm is so inefficient that the time to calculate any Fibonacci number over 50 is simply too much, because basically for every number, you're calculating all of the sums, like calculate. You may go for a cup of coffee or go take a nap while you wait for the answer. So like it's an exponential, I don't know if it's exponential is the right word, but it gradually gets longer and longer because you have to keep calculating all these numbers. And if you were to try this on Code Wars, you would probably get a timeout for any answers. For this particular kata, we want to implement the memoization solution. This will be cool because it will let us keep using the tree recursion algorithm while still keeping it sufficiently optimized to get an answer very rapidly. Memoized, maybe, I don't know if I'm saying that right. To me, it's a cache. It is a place where if we've ran a function with this particular input before, and we're calling that function again, instead of recalculating it, we can just reach into the cache and say, oh, I've calculated this before, take it from the cache. So I think of Memoized as like a cache. So quick break. The trick of the Memoized version is that we will keep a cache data structure, most likely an associative array. In JavaScript, an associative array is an object. You have basically, like we've been doing in pretty much all the katas that I've solved today. I've created some sort of cache, right? I've created this object that holds on to things we've calculated before, so that way in the next iteration we can just use what we already know in that object. Where we will store the Fibonacci numbers as we calculate them. When a Fibonacci number is calculated, we first look it up in the cache. If it's not there, we calculate it and put it in the cache. Otherwise, we return the cached number. Refactor the function into a recursive Fibonacci function that's using a Memoized data structure, avoids the deficiencies of tree recursion. Can you make it so the memoization cache is private to this function? That's a little trickier. Memoize. So Oliver is saying it was Memoize. I'm gonna Google this really quick. How do we pronounce Memoize? Let's look it up on YouTube. Pronounce
Memoization.
Memoization. Memoize?
Memoize.
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 Memoize. Memoize. Memoize.
What's the same pronunciation? Memoize?
Memoize. Memoize.
Hey, how's it going, everybody?
Memoize. 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 Okay. And AJ is mentioning, I saw you do this recently with images or something, if I remember correctly. Because the thing is, we can do caching on the front end, like with like API data too. So like you have a page that multiple things need data from the API, but instead of calling the API multiple times, the first time you call it, you store that data in a variable. And then the next time you like call the function that calls the API, you check to see if you've called it already, and if you have, you just return the data. So yeah, it's absolutely applicable in many different places. Let's try it. Okay, we'll break it down locally. No, sorry, I gotta give the name of the file. Memoized Fibonacci.js. Yeah. Andres is asking, why is this so funny? So, okay, I digress, but yes, there are a ton of YouTube channels with pronunciation. Memoize, like, and so yeah, like that pronouncement, memoize. Where was it? So this is pronunciation guide. It's a whole channel
Memoize.
dedicated to pronouncing words. So like if we look at their past videos, it just pronounces words. But there's a joke channel. The IMDb tutorial. Yeah. So I was sorry. I'm all over the place tonight. But in my video where I was scraping IMDb, in my server side, if we've already scraped that video, I just return the cached version of it. Yeah, good call. Okay. Pronounce Chipotle.
Sean Toodle.
Sean Toodle. So this YouTube account is just a bunch of
Porno.
I'm not gonna play any of them because some of them are like very offensive. But like, if you're like a foreigner trying to pronounce a word, this channel looks a lot like those other channels, but they just give the totally wrong, ridiculous pronunciation of those words. I don't know. It's hilarious. I'm not gonna play any because sometimes they're pretty offensive. Where were we? we were writing this function. Okay. And let us bring down the tests. Okay. Yes, and AJ's mentioning it sounds like we need a closure. That's if we want to do a private cache or a private memoirs. I'll do it without the closure first, but then I'll try to figure out how we do it with a closure. So just because, let's write this as not an anonymous function. So function Fibonacci, and let's give this else statement a body. Okay. So actually, if I were to, I'm not going to run this with Quokka because I think it would crash it. But if I try to run this code with Node, it'll just probably spin for a while because I'm trying to calculate like really large Fibonacci numbers. Let's just try 50 though. Waiting. Yeah, it's not going to finish anytime soon. But this is why we're going to try to memoize it. So I think the simplest way to do it is like let's create our cache. And in the description, it talked about an associative array. Here. In JavaScript, an associative array is an object. It allows you to store things by key and then grab their values. So we have that. And then now we need to keep track of them. So my initial thought is, well, first, like here's what we can do. When you call this function, we can say, okay, if the cache has already computed the number for n, then return it. We found it, no need to do it, return it. So that's like the caching version of it. We're not putting anything in the cache, so if we try to run the function again, it's not going to do anything. But now we need to actually put things in the cache. So hello, King David. Welcome to the stream. Yes. So to do this, we need to actually put these in variables and then put them in the cache. So here's my first thought. Oliver, if you're still watching, you can probably come up with a more clever way to do this. I'm not the best with recursion, but what I'm thinking is we store the result like in1 in a variable, and then we could do that. Should still work. But after we've calculated it, that's when we put it in the cache. So we can say the cache at n minus 1 is equal to in1. And then we could do the same thing with in2. And then the cache at n minus 2 is in2. And then we would just return that. But now, if you think about this, when the recursive call happens, so when it calls itself again, if it sees something in the cache, it just will immediately return it, so it doesn't need to compute it again. So now we should be able to, it works, like instantly. There's no time to go get a cup of coffee. And that's because now in the recursive calls, we've kept track of all of our previous computations. So if we have it, we just return it. Easy enough. Okay, another digression. Let's have some fun, CJ. Say in Portuguese, parallelepípedo. Pipedo? Small paver stones on the floor. Paralelepípedo. That's probably not how you pronounce it in Portuguese. Parallelepípedo? Pipedo? I don't know. Okay. But yes, we've done it. That's great. I think the tricky thing here is creating some sort of closure to where we don't have this global variable. So let's figure out how to do that. Because right now, if I do this, it happens. But because this is a global variable, all of these function calls technically shared this object. See, and so I have a suggestion from Oliver. If you make the loop only handle cache of in, it'll maybe be cleaner. Should work the same. So I guess the idea being let's take a quick break. Yes, and so I guess before I get into that, Andreas is asking, can we explain what's happening here? Let's see this if we do. Let's just log out Fibonacci of 10. So find the 10th. Find the sum of. Sorry, no. Find the 10th Fibonacci number. What does this give us? 55. So 55 is the 10th Fibonacci number. But if I log out that cache, we can see that all of the previously calculated Fibonacci numbers are in that object. So when I go back to calculate, I can just reach in and say, oh, what's the 4th Fibonacci number? 3, instantly, instead of having to recursively call it to calculate it. So when we do it with something really big, basically we have all 70 of the previous numbers stored so that on each successive call, it doesn't have to calculate it again. It just reaches into that object and grabs the previously computed one. Cool. Rodrigo is saying not bad for my pronunciation. Parallelipipedido. Cool. Okay, so that's great. But yes, how do I do this? Here. And Oliver is mentioning make the loop only handle cache of in. So I guess what you're saying is instead of storing cache of n minus 1 and cache of n minus 2, could I first cache in and then just return Fibonacci of n minus 1 and n minus 2? Is that what you're saying? Let's see. Will it work the same way? Well, actually, let me leave this because this one works technically. But we'll do that. We'll do that. But I guess what I want to say is cache at n equals Fibonacci at n. Like that. Will this work in the same way? Let's see. No, maximum call stack exceeded. It's like calling itself. For example, Fibonacci of 70 doesn't cache the value of Fibonacci of 70. So if you keep calling that, you'll continually miss the cache. Yes, and AJ has a great way of saying it, and I've just totally messed this up here when I do that. But the first recursive call is saved so that the second doesn't have to calculate them all. Yes, and that's basically what happens because here we're calculating it and we're storing them as we go. And then this one, when it runs, all of those previously stored numbers are there as well. But if you think about the call stack, like it has to recursively call itself again and again. So with each recursive call, we've kept track of all of the previous numbers. No, it's fine, Rodrigo. It's fun. Oh. Beautiful. Okay, that makes so much sense, Oliver. Thank you. So, yes. So cache of n equals that, and then we return cache of n. And this should work in the same way. Yes. Oh, okay. And that actually is a lot clearer because to calculate the nth Fibonacci number, you need to calculate the sum of all the sum of the two previous numbers, but we need to calculate those two previous numbers. Awesome. And by doing this, we're storing them in the cache for each successive call that calls itself. I like it. Okay. But now, how do we make this not a global variable? How do we make this a closure, or basically like an object that it keeps track of? And so Oliver's mentioning we can remove this check altogether and just return it. What happens if we just comment that out? No, we need. I guess we do need a base case. I'm not sure what you're saying. But yeah, how are we going to make this a closure? I think what we need is well, could we pass in the cache as a parameter? So let me comment out everything I have up here. Could we give it a default parameter? So cache is an object, and then on each successive call, you actually pass it in as well. So that way it's using the same one as it goes. Does this work? It does. This is like a closure in, it's not a closure in disguise. We're basically using default parameters. So the first time you call Fibonacci, cache is undefined, so it's actually set to an object. And then each of the successive calls are passing in that original one. That's one way to do it. Oh, I see what you mean. So Oliver's saying if we start the cache with 0 and 1 having the values, then we don't need to do this check here. Understand. So let me actually go back to what we had without the cache. Beep. Boop, beep, doop. And let's move this one. Oh, let's put this there. Okay. So what we're saying is if we start off with the two values that we know, so like 0 is 0 and 1 is 1, now we don't need to check this because we could just immediately return those. So let's comment this one out. So if we run this, what? If n equals 0 or n equals 1, return n. So this should say, so like if n is 0, it's just going to return 0. If n is 1, it's going to return 1. Why does this give me a call stack exceeded? Any explanation for that? Or am I doing this wrong, Oliver? So that basically calls itself too many times. So it seems like there's still not a base case. Oh, here we go. If in cache, right? Because if this is a similar issue that we ran into earlier because false was in the object. So when 0 is in there, it just keeps calling itself. But if we use the in operator, it'll say whether or not that's in there. That should do it. Yes, good call. 0 is falsy. Yes. Cool. Okay, so that's fun, but how do we do this without having a global variable? This is one way, and this is using like ES 2015 default parameters. I mean, you can do it without default parameters too, but is there a way to do this by not having to pass it in here? I don't know. Let's see. So what we could say is cache is equal to cache or an object. And now we can update this to be the same thing. And then we don't need this anymore if we say if in cache. That should work. So I guess what I'm saying is these two, let's update this. These two are essentially the same. This is just ES 2015 syntactic sugar for creating a default parameter, but this one should work in the same way. It does, great. But is there some way we could create like a function that returns a function that has an object in it? I don't know. So like if we're always calling Fibonacci with in, and now we're not giving it cache, could we return a function? So can we say like const cache is an object, and then we return a function that takes in. And we would do this. Don't think this will work though, because it's creating a new function every time. So this would be, okay, you call it the first time. It returns a function that takes in. But then when we call it again, we're just getting back a function. We're not actually getting back the value. So like, what if we returned this function invoked within? No? No. Because then we're not keeping track of it. Oh, Oliver's making a good point. So yeah, I guess that makes sense. You could, so yeah, what if we wrap this thing in an iffy? So you start it off like this, and you create an iffy. So you have a function that immediately invokes, like this. And this takes in. Wait. Fibonacci equals a function that takes in, and then like calls itself. I'm thinking, yeah, so, but how do we make Fibonacci accessible? Return that? No. I think this would do it. This does it. But technically, that is shared between function calls, isn't it? Which I thought we were trying to get away from. Oh well. We have spent plenty of time on this one. I'm just going to submit it as is. But basically what this is doing is, so if you're not familiar with an iffy, we have created a function that we immediately invoke, and that function itself returns in. So now cache is hidden inside the scope here. It's a closure. It's closed over. And when you call Fibonacci later, you get access to it. And Oliver's mentioning this is probably what they want. But basically, now it's actually very performant because when I call it with 70, it builds up the cache. So like, I don't know the best way to demonstrate this, but I call it with 70, it's building up that cache. And then when I call it with 60, it's done immediately because it's already calculated 60 the first time that I called it. And that kind of makes sense because now anywhere I use this function, it's pre-calculated. Okay, let's go with this. We've got one last pretty hard one to do, so try. Sweet. Attempt. Sweet. Submit final. Oliver is mentioning we could one-line this. Okay. So what we do is put that as a default parameter. And then this needs to return a function. So we're going to make this be parentheses instead of curly braces. Well, actually, sorry. Let me put it back and then we'll write it as a one line afterwards. Okay, so that one's great. Let's see it with a one line. So these these curly braces I'm going to turn into parentheses like this. And then this becomes a default parameter like that. And then I don't need to return anymore because I'm using parentheses. And then this is like that. Okay, we're getting closer. This should work. Yes, beautiful. But now, how do we make this a one-liner? So if in cache, return cache it in, else cache it in equals this, return cache at in. And all of this goes away. Does it still work? Undefined. Well, that's because now it's a default return, so I can get rid of the curly braces. Nice. Okay. let's make this a little bit tighter. Cool. Look at all those parentheses. What is this, Lisp? Okay. That's fun. Okay. Cache of in at the value already returns the value. Oh. So I don't even need this. Less parentheses. Is that what we're saying? Hey. I like it. Cool. Look at that. Okay. Moving on to the last kata. Actually, let's look at some of the previous solutions. Yes. So they did it the way I solved it the first time, where basically put two values in the cache, then return those two values. Immediately invoke to create a closure for the cache variable, and they're returning that function. Very cool. Oh, good call. Oliver's mentioning instead of an object, sorry, where are we at? Technically, we could just use an array because of the way the keys are laid out. Like, this is literally an object where the keys are 0, 1, 2, 3, 4, 5, 6, and the values are the corresponding values. So technically, we could just make this an array of 0 and 1, and it should still work. Yeah, look at that. Cool. Thanks to Oliver, I think we probably have the coolest solution on here. Like, everyone else is meh, meh. Yeah, we definitely got the coolest solution. Okay. I'm gonna stand up. I'm going to stand up and stretch real quick. Get ready for this last kata. This one's potentially going to be a doozy. It really tripped up me and Tony. I think at that point in the video, though, or in the stream, we were probably like 3 or 4 hours in. I'm only an hour and a half in. I have worked a full work day, but I'm going to stand up, do a quick stretch, and we'll get to it soon. Actually, if you've been watching at home, stand up, take a stretch. I'm doing karate chops off camera, you can't see me. Or karate kicks. Okay. Hello, Danny from Spain. Welcome to the stream. All right, last kata of the night. This one is called Snail Sort. Given an n-dimensional array, n by n, return the array elements arranged from the outermost elements to the middle element, traveling clockwise. For example, you're given this array of arrays. You need to return an array that's 1, 2, 3, 6, 9, 8, 7, 4, 5. So you're going like a snail in the array. To see that as an example in order, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, and you get the new array. Or to see it illustrated, you go like this. And you have to do it with any size array. So it goes like this. So, no, the idea is not sort the elements from lowest value to highest. The idea is to traverse the 2D array in a clockwise snail shell pattern. The 0, 0 empty matrix is represented as array of array. Okay. I'm a little bit scared, but let's do this. It's a 4Q. Oh my goodness, there are no example tests. Well, that's lame. We'll create some of our own example tests. It should be easy enough. Let's bring it down locally. We need snail.js. Let's create a function called snail. Really, it takes in, let's call it a matrix. And let's show some examples down at the bottom. AJ says, I have to thank you for convincing me to take more breaks. Love timeout. You're very welcome. It helps, like, especially for like long work days. It's a good just, the thing is you, in a work day, you don't realize like how much you're working or how long you've been sitting. And it's a simple reminder, just like, hey, stand up real quick, stretch those legs. Like so, and we should get back this. Okay, and let's say result is this, and let's log the result. Okay, if we start up Quokka, right now we get back undefined. All are saying two free, yeah, so these are the tests that we'll be testing with it locally. I mean, technically, like one of these days I need to contribute here, because you can actually upload your own tests for a given language. It could be that this one with other languages actually does have tests, but it's fine. And hello, Winkle, welcome to the stream. All right, but how are we gonna do this? Okay, so we need to iterate over the array. Obviously, we need to keep track of what column we're in and what row we're on. Okay, so easy enough. Keep track of current row and column. We also need a place to store the, what do we call this thing? The unraveled snail. So we're gonna have like an array where we're gonna put these things. We keep track of what row and column we're in. And now we iterate up to the number. Wait, do we iterate? No. I think maybe we should do this with a while loop. So we iterate while the unraveled snail's length is not the desired length. So like while the, is there a better name for this? Let's just call it array. So while the array length is less than the desired length, and that's going to be n times n. So this is a 3 by 3 array. So ultimately the length we're going to end up with is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So while the array length is less than 9, we will say, oh gosh, if we need to keep track of, okay, are we going this way, or are we going this way, or are we going this way, or are we going this way? Wow, okay, this is gonna be hard. Yeah, and Rodrigo is mentioning, saw someone on Twitch programming, and if they had a problem they couldn't solve, they would stand up, take 2 steps back, and figure out a solution. So yeah, they're like getting a new perspective. But let's think about this. So we're keeping track of row and column. So while the array length is less than the desired column, we need to start off at the top left. So keep track of row and column, initialized to 0 and 0. So we start at the top left. And maybe we keep track of, right now we're going right. I guess the other thing to think about is, like, as you get to each successive level, how much less are you iterating? So iterate up to the number of columns. So we're keeping row at 0 and incrementing column up. Then when you reach the number of columns, iterate down and then repeat. So the number, I think I've got something. Okay, so the number of rows and columns each time is gradually getting smaller and smaller. So you do the outside, and then you do the inside, and then if it's even bigger, you do the inside again. Okay. So, okay. So while the array length is less than the desired length, if column is less than, so if current column is less than number of columns, then we increment the column. Right, and Rodrigo's mentioning, I want to see your solution working with 100 by 100. And I think it should. So like whatever solution I come up with needs to be general enough that whatever we pass into it just works. Okay, so if the current column is less than the number of columns, increment the column. So current column is 0, increment. We get here. Okay. Else, increment row. So then we're going to start going down. We're going to keep column the same. So else, if row is less than number of rows, increment the row. Else, we then need to start, so if the current column is less than the number of columns, we're incrementing. Then when we reach the end, we need to start incrementing the row. So if the row is less than the number of rows, we start incrementing the row. Then when it's here, we start decrementing the number of columns. So else, if current column is greater than 0, then we decrement the column. Else, if the current row is equal to the number of rows. Well, sorry, if the current row is greater than 0, we then start to decrement the row. Okay, so this is like our base case. This is iterating over the outside, right? But when we get right here, that's when we need to start iterating over the inside. So if we then keep track of the number of rows and columns, we can keep track of like how many are left. So like here, when we get here, now it's the same problem but with a 2x2. Psh, done. Oliver's asking, should I get you a test case for that? If you wouldn't mind. I know that's going to be a little bit of typing. Try it. Yes, please. Send me a 100 by 100 array, and I will definitely run my solution through it. Okay, I think we'll do this because this will at least get us the outside edge, and let's just make sure that at least we're getting the outside edge. And then at the end of it all, we will return the array. Okay, let's start. So I need an array. It'll be like that. We need to keep track of the current row and the current column. So we'll say let row equal 0, let column equal 0. So great. While the array length is less than the desired length. Again, I just want to make sure that the outside edge is working, so I'm just going to do a while loop. Let's say while array.length is less than 1, 2, 3, 4, 5, 6, 7, 8. 8, because I just want to grab the first 8 numbers, just to make sure it works. Now we have our logic. So if the current column is less than the number of columns, and let's actually store this in a variable. So let's say let num columns equal matrix.length, and let num rows equals matrix dot length. It should be a square. So if the column is less than the number of columns, then we need to increment the column, so column plus plus, and I guess before that we would have stored the value. So here we would say array.push matrix at row and then column. Okay, so in this case we've just pushed in 0, 0. We pushed in 1. Now columns is less than number of columns, so we increment the column. Great. And that should now push in the next one. But we'll say else if row is less than the number of rows, then increment the row. And so then that will start putting us there. Else, if column is greater than 0, we will decrement the column. Else, if row is greater than 0, we will decrement the row. And then we'll return the array. Cannot read property 3 of undefined. Let's see what's happening here. So if we log the current row and the current column, so we have 0, 0, 0, 1, 0, 2, 0, 3, wait, 0, 0, 0, 1, 0, 2. We've gone too far. Yeah, 0, 0, 0, 1. We need to stop at 0, 2. So we need to actually say number of columns minus 1. Quick stretch. Yeah, and Rodrigo is asking, is this a nested array? Yes, it's an array of arrays. So we have our outer array, has inner arrays inside of it. But what I'm thinking is, so right now, I think I'm actually doing a decent job, but what's happening is we're going one column too far, and then we're hitting the bounds. So I think this should be number of columns minus 1 and number of rows minus 1. Okay. And then we end up with an array that's 1, 2, 3, 4, 5, 6, 5, 6. Okay, so we've gone wrong somewhere. So we have 0, 0. I need something to point at. So 0, 0, 0, 1, 0, 2. And then, we're doing, no, that's right. So 0, 0, 0, 1, 0, 2, 1, 2, 2, 2, 2, 1, 2, 0. So we're not decrementing. If column is greater than or equal to 0, and row is greater than or equal to 0. Right? And Oliver has mentioned, I now have a 100 by 100 test case that I can try this with. Okay, so 0, 0, 0, 1, 0, 2, 1, 2, 2, 2, 2, 1, 2, 2. So we've reached the point, we've at least reached the bottom left. We've reached this. So we reached this, and we're not actually getting the value. Well, actually, sorry, we've reached 1 before it. We got to the 6, but we're not going 1 less. And so that's going to be the case where, so row, right now we're decrementing columns. So columns is greater than or equal to 0. Not equal to, just greater than. This should be just greater than. So if the column is greater than 0, we're decrementing it. Because we would have grabbed row column here. I guess instead we're getting 5, 6. Do I have this mixed up? Does this need to be column row? No. No. Okay. So if the column is greater than 0, then we subtract the column. So we would have gotten back to, or we should have at least gotten back to 2, 0. But 2, 0 isn't happening. It's going from 2, 1 back to 2, 2. So we're actually incrementing the column. We're going back here when we shouldn't have. Because when column becomes 1, 1 is less than number of columns minus 1. So, oh yes, okay, here's what happens. We get right here, and it starts incrementing back in this direction. We don't want that, so we want to check which way are we going? Should I have another variable to say, like, are we going left? Are we going right? Are we going up? Are we going down? Might be interesting introducing too many variables, but I think that will help, because this case should only be checked if we have now if we're going to the right, right? Like if we're incrementing columns to the right. But what's happening is the moment we get here, that's satisfied, and then we start going in the opposite direction again. So I need to do another check. So if column is less than number of columns minus 1, and like column increasing, then increase the column. So this, I don't know, this might be too much, but what I'm thinking is I need some more variables. I need something like column increasing is initially true, and row increasing is initially false. And can I do it with just two variables? So is the column, if the column isn't increasing, then potentially the row is increasing. I think I need 4 variables. So then I could also say column decreasing is initially false, and row decreasing is initially false. So okay, if this is true and the column is increasing, increment the column. Else, if this is true and the row is increasing, we're gonna have to swap these, but initially, okay, but now at this point we need to swap it. So when we get here, we need to start saying, yes, you are increasing in row. So let me look at the chat. I'm having some suggestions here. So adding a new variable makes sense, but I would just do a variable called direction. That is 0, 1, 2, 3. But I guess it's not as clear. Yeah, so we could have, if direction is 0, that means column is increasing. If direction is 1, row is increasing. And then Andreas is saying, can you check for both column and row on each if statement? So in each if statement, look at where we are and decide where we're going. But the thing is, we lose track of where we're going. Yeah. And hello, Mohammed. What kind of programming is this? I'm just solving problems. So if you, I don't have it in the description, but I do have a GitHub repo where I have links to all of the katas that I've previously solved. And right now, I'm trying to solve this one. It's called Snail. And there is a suggestion from Skelly. Does column number mod 2 equals 0 work? So if the column number is even, do what? All right, okay, so, so now we have to decide how do we change which direction we're going. So if column is less than the number of columns, when column increasing, we increase the column. Okay, but now when do we decide to switch? When do we decide to say, okay, we've reached the column, now row is increasing. Okay, I think we'll do it inside of here. So we'll say if column is equal to number of columns, minus 1. Row increasing is true, and everything else is false. But now do I have to reassign all of the variables every time? Ugh, okay. Row increasing is now true. Everything else is false. So if the column I can't do this in here. I need to do this after I've already decided. So if the column is equal to the number of columns, that means we've reached the end of a row, and now the row needs to start increasing. Else, if the row is equal to number of rows minus 1, then now we are decreasing columns. So column decreasing is true. Else, if row is equal to, now we're decreasing columns. So if column is then equal to 0, now we're decreasing rows. Else, if row is equal to number of rows gotta figure this out. So basically, for now, let's just see what happens. Let's see what happens if I do this. So we get to 5. So we get to 1, 2, 3, 4, 5. And now we need to say that column is decreasing. So I got that wrong. So if column, we're never setting, so else column decreasing is true. And everything else is false. Oh, and good call. Oliver's mentioning, technically you could figure out which direction you're going in based on where you are in the matrix, but that would be a pain to figure out. Let me see if I have my logic here right, though. So if the column has reached the end, meaning, so if column is number of columns minus 1, then now row should start increasing. Great. Else, if the row is equal to the number of rows, minus 1, then now column is decreasing. And then if column equals, this would actually run like in the first loop though. Oliver's saying the issue you have is in the corners, it'll want to stay going straight. And I guess that's what's happening. So it's getting at 1, 2, and then it just goes back. I think the thing is I only need to set these variables when when I know that I've reached the end of the row. If column equals 0 and row and column decreasing. So if the column is, which means if I reached 0 and I was actually decreasing columns, now I need to start decreasing rows. Else, if I was increasing rows, then I need to start decreasing. And I guess technically, yeah. Okay, we're getting a little bit closer. Yeah. So let me read through Oliver's comments. If column equals number of columns minus 1, it will want to stay going down. Rodrigo is saying, if you get the right edge, iterate through the last index of each array and parent to then take the last one, iterate in reverse. Wait, what? Oliver's mentioning if you put them inside the other if else you were doing, I think it works better. The one thing that I caught though is, okay, so we're incrementing columns. Great. But when we reach the end, this if statement isn't going to get called. So, or is it? Or? No. I'm getting a lot of suggestions. I'm also getting very tired. let me think about this for a second. This is where some of my issues are right now. I also don't like how many variables there are here, but sip some water. So Miguel is mentioning you can have four for loops inside the main while loop. Each one with 2 variables start and end. After each loop, you increase the start, decrease. Each loop is for one of the 4 directions. Not exactly clear on what you're saying to do. Oliver is saying it does get called when moving onto the corner, which is exactly what you want. So I guess what you're mentioning, these can go in here. Because like my one worry is, okay, so we're incrementing columns. We need to check, I guess we could check -2, right? So this check right here, let's comment this stuff out. So we're incrementing the rows, great. But then, if the column is equal to, oh yes, because you check it after incrementing, right? So we increment. That's going to put us at like the last value in that column. But then if we did reach the last column, row is increasing. Okay. This we're on to something. Okay. Okay. And then inside of here, I don't need to check column decreasing. Yeah. And this is where I need to do if row is equal to 1. Well, not 1, it's I guess for now let's just say if row is equal to 0. But I think this will get us, yes. Yes. So we have done 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is what I wanted to get to, because at this point now we can start like decreasing the number of rows and columns and like just do like a mini one. Okay. But I've done it. I've at least iterated the outside edge of the array. Okay. Oliver's saying, yeah, you can also do this all with array popping and shifting, which is a nice way to do it because you do a whole site at once. Oliver's saying, if you put the check after the plus, yes, and so that's what I just figured out. Like before I was like, okay, I'm doing this check, but it'll never make it in here if number of columns is number of columns minus 1. But technically it will be if I increment the number of columns first. Cool. Yes, and Oliver's, and this is where my mind's at too. Now I just need variables to keep track of like what are the min and max, or like what are the number of rows and number of columns. Cool. Yeah, this is good. I can think about this better if there's more in the middle section. So let's actually try it with like a bigger array. Let's comment this out. So we have, let's do 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let's line this stuff up. Okay, so this is a 4 by 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, messed up. 13, 14, 15, 16. Right? Because this should do. Yeah, missing 30. Yeah, I went one too far. I caught it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Cool. And I guess now if we run this, I should still get up to 8. Cool, but what if I make the minimum 12? I should at least get up to 12. Cool. So it's working with a slightly larger array, but now I need to account for, okay, now that we're here, we now have a min and max for what the rows and columns can get to. And initially, the minimum column and the minimum row is, so minimum column, minimum row is 0. And the maximum is num rows minus 1 and num rows minus 1. Then, when we go in 1, the minimum is going to be 1, and the maximum will be length minus 1, which would be 3. 2. We'll figure it out. Yeah, Andreas is saying there has to be a better way to track the direction. There probably is. I'm gonna leave it the way it is right now while I can, because I can think about it this way, and then we'll refactor it. But next step, let's keep track of min and max row. Look at all these variables. Yeah, this is ugly. Okay. Let min row 0, max row will be num rows minus 1, because we're at 0-based indexing. And then we need the same thing for column. So so when we're calculating here, minimum possible row is 0. I guess technically, if we take what we have and we say, okay, so the last place we end up is 1, 0. If we keep going with the code that we have, then technically it would go up to 0, 0. We don't want that. So when we reach the place where we need to start, like on the next one, how do we calculate that? So how do I know that this location right here is where we start the next inner one? Oliver has a suggestion. Change all of your if conditions to new variables, and then just edit the min-max when you hit the corner ifs. So I see. I think I get it. Let's take a quick stretch, quick break. Because right now, I'm checking to see number of columns minus 1, right? So if column is less than that. But that's going to be our variable now, and which I'm setting to right here. So anywhere I have num columns minus 1, I actually need to make max column. Max column. Okay. And then anywhere I have number of rows minus 1, I need to make that max row and max row. And then anywhere I have row equals 0, I need to say min row. Min row. And then anywhere I have 0 for the column, I need to say min column. And min column. Should still work, but now they're just in variables, right? Still works. But now I need to figure out, when do I reassign the min row, the mins and maxes? I have a hint from Oliver. When you start going down, you increase the min row. So when we get here, we actually need to start incrementing the column. And we are setting that, right? No, so this would have been row decreasing. So when we're decreasing the row, if row gets to min row, should min row be 0 or should min row equal 1? Min row is 1. So when it reaches here, not column decreasing, it's column increasing is true. Right, so when row is equal to the min row, which means we've made it to here, column increasing is true, and we now need to set min row plus plus, and min column, min row plus plus, max row minus minus, min column plus plus, min max column minus minus. So we move in. I think we've done it. I think we've done it. And so now, while array length is less than num rows times num columns. Oh. That's amazing. Oh, wow. Okay. Hey? Can I get some applause, please? Okay, we've done it. We've done it. Now we can clean up the code. But yes, this is great. So because the thing is, once you reach the min row, then you're ready to move in one and do it again. And then move in one and do it again. So Oliver mentioned that they sent me a 100 by 100 array, matrix to try it out on. Let's check it out. Oh, cool. So this is a 10 by 10 Yeah, let's check out this gist. Whoa. What is happening here? So this is, no, this, is this an array of arrays, or is this an array of, this is just one really big array. The 100 by 100 is where? This one? By 10. Yeah, let me just run this code and see what I get. Let's do it in Node. Oh, cool. So this gives me a 10 by 10. Can we write some code? I would think we'd have to use the existing code. I was thinking, can we write some code that like fills it in the correct order so that I know that it's actually right? We could do it by we could just do it by hand though, just to double check that it's right. Okay. There's that one. Oh. And I appreciate all the applauses in the chat. You guys are great. AJ says, you guys are super smart. Yeah, shout out to, so Oliver, Oliver keeps me honest, and Oliver usually provides the key bit of details that I need to actually make this stuff happen. So shouts out to Oliver. Okay, so there's that, and then let's log the result. Yeah, how do I, let's do this in Node so I can, we'll do it one at a time to make sure that it's it's right. Okay. Whoa. Oh, you gave me the expected output. Is that what that second one was? Oh, and let's get rid of all these console logs up here. This code is a mess. I really have to think about how can we clean this up. That. So up to 9, and then 19, 29, 39, 49, 59, 69, 79, 89, 99, 98, 97, all the way up to 90. And then 80, 70, 60, 50, 30, 20, 10. And then 11, 12, 13, 14, 16, 17, 18. And then 28, 38, 48, 58, 68, 78, 88. And then 87 down to 81. And then 71 down to, 31, 21. Wait, did we already make it? Did I mess up? I might have messed up. Actually, here's an easier way to check this. So we'll go from a 4x4 to a 5x5. So let's say 5. Sorry. 5, 6, 7, 8. Wait, why are we passing multiple things into Snail? That shouldn't have been happening. Okay, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Let's line these up. Please bear with me. I want to check it on something that's like a little bit easier just to double check that I've done it right. Okay, 17, 18, 19, 20, 21, 22, 23, 24, 25. So can we do this? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And the result is 1, 2, 3, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay. And Oliver says, yeah, that's the expected output. Yeah, so check the output against the provided. So you did provide a solution. Let's double check that. So, wait. Wait. No, we're doing the 10 by 10. Okay. And this is, so if I were to go in this direction, this is the expected output, I think is that what we figured out? So if I do this one, let's say result dot toString is equal to that thing dot toString. True. Okay. I've been streaming for 2.5 hours. I do have to go to bed at some point, so let's just see. At first glance, is there anything that I can do to this solution to make it like a little bit less verbose? Maybe get rid of some of the variables. You know, I'll keep it the way it is with all the comments and everything up here, but then I want to try to refactor this to look a little bit nicer. Okay. Oliver said that's a wonderful way to test equality. Yeah, well, and so for those of you at home that didn't realize, in JavaScript, two arrays are not equal to each other. So you could either check all the values, or if you turn them into strings, they will potentially be equal to each other. Okay, let's get rid of all my comments. I'm interested to see like other people's solutions. Like, were they as verbose as this? I mean, we've talked about in the chat. there's like ways to shift the array and do different things like that. Rodrigo says a new boss appears in the chat. The amazing round snail. We should totally have a chatbot that's like you can play games in the chat. Okay. Well, let's think about this. So it's a lot of variables. Is that necessarily a bad thing? I don't know. Because, so one thing we mentioned earlier is we could have a variable that's either set to 0, 1, 2, or 3. And if it's 0, that means row increasing. If it's 1, that means column increasing. However, that would be really hard to read and understand in the code. Yeah, AJ is mentioning enum for the increasing and decreasing. So like in JavaScript, we could do like direction is an object, and it has like right, down, left, up, and then we could just use this. So anywhere where I have column increasing, Oh. Well, I don't want to replace, sorry. Anywhere I have column increasing. So that one, that one, that one, that one, that one. We'll say direction dot right. And initially direction dot right is true. So that gets rid of that one. And then anywhere I have column decreasing, we'll say direction dot left, column decreasing. And then anywhere I have row dot decreasing, or sorry, row increasing, this is direction dot up, oh sorry, down, because the row is decreasing, down. And then anywhere I have row decreasing, this is direction dot up. And then now, how can I, these times whenever I reassign the whole object, is there a better way to do that? I can say something like object.keys at of direction dot for each key direction at key is false. So that resets everything to false, and then we just set the one we want to true. That's kind of nice. So basically, anytime we need to reset it, set everything to false, and then set the one thing we want to true. Let's put this in like a function. So this will be like reset dir. And this will be an arrow function that just does that. And so anytime we need to, we'll just say reset the direction and then set the one we want to true. I like that. That's cleaning it up a little bit. Let's do that here. Oh, no. Let's do it here. And does it still work? Still works. So Alicia's saying number of row equals number of columns equals matrix lengths. Yeah, so that's definitely, so because they all equal the same thing, so we could definitely do that. So the only thing about that is yeah, how do you do a let variable that's defined in line? Because technically this works, this will do it, but it like creates a variable called numRows. Or I would need let numRows be a variable. Sorry, do it like this. Number of columns equals that. Because like, can I do num columns comma num rows equals that? Is that valid? No, it's not valid. So it's a little tricky with let and const. Like, we could do it with a var. let's see. Oh, good call. Yeah, so instead of having num columns and num rows, it's just one variable called matrix length. I like that. Quick stretch. So let's do like, yeah, matrix length. And then I think we only access it right there. Everywhere else we don't. Cool. And let's bring our row and column down here. And technically, both of these are exactly the same. So, right, yeah, we could just have a min and a max. And then min max will just be max. Max, 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 and then everywhere else is min, 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 min. Okay, it's getting a little better. Yeah, I mean, it's looking better. I like that. Yeah, so the description on Code Wars did say it was in by in, so we should be okay by assuming that length and so number of rows and number of columns is always the same. But this is a bit more readable now. We don't have as many variables. We have like current row and current column. Yeah, I like that. I'm pretty happy with this. It's like, it's less variables, but it's still as readable. Let's make sure it still works. Does not work. What did I do? Let's let's double check with one of these other ones. Oh no, we done messed up. So now when we get to here, we get to 9 all day. I messed up with some of my variable replacement. Let's go back to what we had for a second. Apologies. Okay, if I put those variables back, it's back to normal. Cool. Oh, that's why. Min row starts off at 1. Min column starts off at 0. Yeah, so Alicia caught it. So our mins are different, but technically our maxes are the same. Okay. Yeah, max, 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 max. It's tricky. I mean, if we wanted to be clever about it, anytime we're trying to access min row, we could just do min plus 1. I don't want to get that clever though. No, Oliver's saying go back to what I had after the replacement. I don't know if I want to. It's working right now. Yeah, and so that's what I just mentioned. So I could change the last if to be row greater than min plus 1. Is this the only, where am I accessing min row? Min row. Min row, min row. Yeah, that's the only place I access it. Let's do it. I like that. So we could say, whoa. I went to the wrong place. Here. So, yes, let's start min at 0. Min, and then all of our all of our mins. Oh, sorry, no. Let's keep min row because we know that's the one we got to change. It's just min. Whoa. Yes. But this needs to be min plus 1. Min plus 1. I like it. Does it work? It works. Cool. No, I like that, Oliver, actually. Like, it's because it's clear enough that our rows, in this case, always need to be one more. Okay, I think I'm going to call it there. I've been streaming for about 2.5 hours. Yeah, 2 hours. 2 hours, 40 minutes. It was a fun time. This very last one was super tricky. Thank you all for sticking with me. Shout out to Oliver for all of the help and all of the test cases that they sent out that helped to like show up for bigger. Actually, I mean, I'm saying that we figured this out. I haven't even put it into Code Wars yet. I mean, what we tried it with works, but let's make sure. Does Code Wars like our answer? Sample tests. There are no sample tests, actually. Those are going to fail. Attempt. No! We forgot the base case. So if the length is 0, we need to return just an empty array. So if matrix length is equal to 0, return empty array. Oh, just return array. We already have a variable. Attempt. Wait, what? Oh, sorry. If matrix length equals 1, because it's a 1 by 1. No. There's one case I didn't figure out. Okay, let's make sure what I'm getting. I was so close. I was so close to ending the stream. Okay, so this works. Did they talk about the base case in here? The 0 empty matrix is represented as that. No, it is length 0. Yeah. Oh no, the length is okay. I see. If matrix at 0.length is 0, then return an empty array. That's the trick. Okay. Yay! Yes. Rodrigo, that's great. We need to do that. We need to build like an in-chat game where you can like interact with it. Okay, submit final solution. Whoa, not that. Yay! Okay, let's look at people's clever solutions. Steal the first row. Obviously that's clever. Like, if you're going to the right, just grab the array, right? You don't need to iterate over it. And they do the same thing there. Expand, concat, reduce. You know what? I'm done. I like how verbose our solution is. Because, I feel like if you logically think about this problem, and we are like doing the snail pattern of going like this is the code that you would come up with. Cool. All right, I'll push this code up to GitHub. I mentioned it at the beginning, but if you go to github.com/codinggarden/code-katas, you can see all of my previous katas as well, and I'll push up the solutions that I did tonight. Shout out to Oliver for all the help and the sample solutions. Shout out to Rodrigo for making a game in the chat. Sort of. And thanks to everyone that tuned in. Most likely there will be a noob quest stream on Saturday. check out the channel to see upcoming things. I will put it in. There's an upcoming streams list that I'll add when I do know that it's going to happen. Also, shout out to all you wonderful people out there. I have made it to over 3,000 subscribers. It's awesome. And a plug. So I decided during the stream to actually release this Build a CRUD Client with React course. So it's it is 16 videos that walk you through using React 16, React Router, and Bootstrap to build a client for an existing CRUD API. So if you click on playlists, you can check that out. And I think that's it. See you all later. Thanks for tuning in. Wherever you are in the world, have a wonderful morning, afternoon, evening, or night. We'll see you next time. Here is this.